Then he's up at the end of like what I see. Yeah. And they were asking me to
Hey guys, we got two things now, and this is going to go live on YouTube channel as well, second. And we'll post a link to it on the Discord as well. There you go, so there. Yeah, so this is going to be real quick because I know once we are on, I hear that you're right here on the program. So, yeah. Okay. Well, so it's just the workshop is going to look like this. Then you got both you the chat and why is it like that? That you are going to be so let's take a simple feature which is applications to a project that you're already working on. Essentially, you take some payment and then you charge everyone to whatever you want to check out for that. And again, you can say, hey, pay this much, and then the transactions maybe. So that's a pretty simple feature. And let's say you've done relations and payments on a website. How do you what do you expect it to do? Probably like 20 minutes, right? And then you make it in cash time, you don't have any done. But I don't think that's what actually happens. Let's see what happens. So first, you need persistence. You need the ability to store someone's transactions so they can be able to calculate so they can see that on by base $20 for so you need to make someone's transaction. And for that, you make the and then example that on screen, again, what you like, all of these minutes. Okay, that please. Okay, now the next so you can ask the facts. So you find nothing it's fast, states, and pictures, but ask you see my that. And now you have
what the columns of your table is going to return. That makes sense too, because you want to be able to validate the output from your table. Finally, you make a fetch request from your front end. So you can actually call that resource and display that to the user on the website. So the backend knows what the payment object looks like, but the front end doesn't. So you define an interface so you can actually validate the return type. And therefore, you see this being repeated once more. Finally, let's say you add some like agentic. I'm guessing most of you will add some kind of agentic mode. So along with defining all the tools, you will also be defining the type that the model explains, the model might expect to see. So right there, you can see the cart item being defined at the top so that the model knows what input to expect. So yeah, we just need to tell the LLM how long the user spent shopping and how much they purchased. Okay, each of those steps taken individually made sense, but overall, you just defined payment four times. Once for the table, once more for the backend, once more again for your website or the client, and finally, if you wanted to use it with like an LLM. So you have 20 lines of code before you even start implementing any functionality, because this is just glue code that tells each like scene, or I guess every part of your application what to expect. Apart from this, you still have the actual like Stripe functionality to implement. So you can see that like line count balloon up. Like I said, every layer in your application is sensible when taken by itself. It makes sense that you want to be able to validate on the backend. It makes sense that you want to be able to define tables. But taken together, the complexity is overwhelming because the backend doesn't know what the frontend knows, and the database doesn't know what the backend knows. Yeah, there's a real reason for each layer, but together they don't play well at all. Leaves you rewriting the same types and definitions over and over again. The solution to this is essentially what one of Jac's, I would say, main advantages. Receiving, which is database, processing, storing, querying, and displaying data are first-class concepts. What this means is Jac, the language, embeds these application like scenes as part of its compiler. So the Jac compiler knows what a backend is. The Jac compiler knows what like databases are, and it also knows what like websites are. And this is not something any other language does. What this means is you now have type checking across your entire code base. So the compiler is able to have you define the table type once, and throughout the backend and the frontend, you can like reuse that type without having to redefine it at each step. Let's look at an example of what this looks like. So on the screen here, you see a simple application which essentially just sends you a greeting. But you can see the different scenes or like different layers present in a single file. So up top, I have the type definition for the table. This basically takes in a message and stores that as a chat message. So yeah, I have the chat message being defined. It has a text, which is a string, and then it has a sender, which is also a string. So it stores the date as a string as well. And then finally, total, which is just like an ID associated with that message. So throughout the entire app, notice how that's the only part I define my type at. If you were to use like a polygon stack, which isn't Jac, you'd be defining it one time for each scene. So like I said, the database, backend, frontend, and once again for like your AI calls. So again, since the language knows what a backend is, the part of the code that my cursor is on is actually what an API request looks like. So you can see that it looks exactly like the rest of your code. And I don't have to redefine what chat message is, because I'm just reusing the same type I'm using for the table. And this part here that says DB connection, this is actually how Jac connects to Postgres. So all you need to say is this thing here, which is basically appending a message to the database. And that's it. You don't have to set up database connections. You don't need to do any of that. It all comes with the language and the compiler. Here at the bottom, again, you have React, also in the same file. And essentially what this means is that I didn't have to write out like an API request. I don't have to say fetch this endpoint. All I need to say is call this function go, which calls this function send. And if you look at where send is defined, send is actually defined as an API endpoint. So what's happening is I'm able to define my API endpoint once and then reuse that as a function. Because in the background, like the compiler abstracts all this away and makes it into like a regular like I guess like a GET request. So in a traditional application, you'd have to write fetch and then like write out the endpoint. But here, no, you just call a function and you're done. So what problem does this solve? The problem this solves is let's say you wanted to add a new column to your database. Let's say I wanted to also keep track of the receiver of the chat message. In a traditional application, you would add the column to your table, and then you change your backend to recognize that additional column, your front end to recognize that column, and finally, like also your AI model. But here, all I need to do is add that into my chat message object, and that's automatically picked up by the rest of my application. So what this means is you can literally make anything with Jac. So we support native binaries. Honestly, if you make anything with like native, I'll be super impressed. So that's kind of like a tip for the hackathon project. You can make backend APIs. You can make full stack apps. You can make desktop apps. You can also make agentic apps. We have some helpers for agentic functions. And finally, you can make packages that you publish on PyPI or NPM. Okay, so if you haven't been listening so far, this is the part I would lock in on because this is, I know some of you have already started coding, but this is how you essentially start off with installing Jac. You can either use the docs manually, so you can go to the docs and check out how to install Jac, or just tell your agent to use our LLMs.txt to install it. We also have a homebrew pathway, so that's something you can do on macOS. Yeah, this is, I guess, the more important part. I'm not sure if all of you have this set up, but the Jac binary itself ships with an MCP. So just have your agent add the Jac MCP to your Claude code or OpenCode or whatever harness you use. This will be super useful for looking up documentation because your agent probably doesn't know to write Jac. Yeah, like I said, this is a new language. So this is kind of like a must-have in my opinion. So yeah, this is kind of how you do it. Reach out to me on Discord or just in person if this doesn't work. And Jac also ships with guides, which are basically kind of like skill files. This might be like more esoteric information. So this is kind of how you like add these skills to your Claude code content. Just add the -- export flag and pass the path to your skill files directory. And that's pretty much it. Once you have the MCP and the skill files, your agent should be able to speak native Jac and write it just as well as it would maybe like Python or JavaScript, for instance. So if nothing else, this should be your takeaway. This is how you set up your agent to begin programming Jac. And that's it. So Jayanika will be taking over from here to cover a short walkthrough of one of the projects we have going on, so you can take a look at what Jac looks like and get a feel for what how it feels to write Jac. Yeah.
So guys, so we have a bunch of repos in Jaseci labs, like we just go to JacHacks. So if you go to like our GitHub repo and our like organization, there are like a bunch of code bases in there. For example, this is kind of like exemplary Jac code. It's called.
Oh.
This is Jac. This is Jac. So you have like two ways of like examples of showing off what Jac looks like. And there's another repo for your AI to like look at and see what's not Jac. So that's also there. So these are some repos that you can access on our Jaseci Labs GitHub organization. And I'm going to show you a little quick demo of this agentic AI tutorial that we have on there. The agentic AI tutorial. It's basically a very simple way to like introduce you to how to build agents using Jac. I'm going to quickly walk through like I'm not going to go through all the details of how to build agents. I'm going to show you quick examples and how to connect them to the front end and show you like so for example, I'll show you like how AI is being managed from the front end side. So this is the app I'm talking about.
I
So
can't see your screen. Can't see your screen.
let me just switch. Cool. Okay, so yeah. Cool. So this is like a demo app that we have here. So you can say basically a hackathon pitch builder. You can just say music and Python and do like yes. So this is a front-end application, but written in Jac. Like if you go to app.cl.jac, this is basically like all the the front end for this application. And in this application, what's interesting is that, like for example, this root spawn run structure, or for example, I'll show you. Okay, root spawn run research. So this run research, if you want to find where it's defined. So it's defined in this app.jac as an endpoint. So you have this endpoint defined here as a walker on research, and you just use it here. Just root spawn this agent and it works. And that's basically how you connect your agents to your front end. So that feels like a with the agent integrated. Yeah, that's basically like you can basically go through this report, use AI, you can see as an example, and there are a bunch of more examples in the organization as well. And yeah, so that's basically yeah, how it's all Jac and
Also, I'll be here all day, so if you have Jac-related questions or if you want to talk to me about your project, yeah, you can do that. I'll just be around. Same thing with like I guess janitor. Yep. Yeah. I'll also be a judge, so you can ask me what I think of it. So yeah, that's another thing you can do.
cool. Okay. Thanks for joining us, and let's get hacking. Right.
Wow, it's cool. It's cool.
I have a question. You said both of you guys can be judges. We're still iterating over our idea, and we have a.
Yeah, I can come to your table.
No, we're not done yet. We want to pitch you something we actually have, right?
Yeah.
We're gonna be done in a bit. Is it cool if I just like grab you after we're done in a bit?
Yeah.
And I can grab both.